which is incredible. I love that name so much. Okay, so take a look at this. Titration of a weak acid practice. Hydrogen cyanide gas. How do I know that that's a weak acid? It's not one of the ones. And also look at the Ka. 6.2 times 10 to the negative 10. That's a very weak acid, yes. When dissolved in water. If a 50 milliliter sample of 0.100 molar hydrogen cyanide acid is titrated with 0.100 molar NaOH, calculate the pH of the solution at two different places. Place number one is at the halfway point of the hydration. So, if you remember, looking back at your notes, remember how we had the titration curves that looked kind of like this? Yes? From the notes, halfway point is here, equivalence point is there. Yes? Okay. So, the halfway point, there is something special about it that is in your notes. Anybody remember it, or anybody want to look back at their notes and see what is special? There's something special about the halfway point. Or the midpoint is what I called it in the notes. You can get your notes out and look. That is allowed. We talked about this. What? Something has the same amount. True. But what two things? Not reactants products. What'd you say? Yes, at the halfway point. At the halfway point, we know there is equal amounts. There's equal amounts of, you were on the way, Ella, acid and base present. Or, this is where the volume added is half, I know this is crazy, of what it will be at the equivalence point. So let's say my equivalence point is at 8 milliliters. What is my volume going to be here? Yeah, it's going to be 4 milliliters. We also know at the equivalence point, as Audrey just said, pH equals pKa at the equivalence point. So this would be a great question on the AP test where it looks hard, but really, what is the only thing you have to do here? I have Ka, I need pH. pH equals pKa.
Take the negative log.
Take the negative log, because I need the pKa. So I'm going to take the negative log of 6.2 times 10 to the negative 10th. Negative log of 6.2 times 10 to the negative 10th. What do you get for that? Anybody got Desmos up? 9.2. Joe is on it. 9.21. Yes. So 9.21 for letter A. Letter B. Letter B says at the equivalence point of the titration. Well, what is equal at the equivalence point? At the halfway point, I have my acid and base equal. Do you guys remember what's equal at the equivalence point? At the equivalence point, what is equal to each other? It's two concentrations. Concentration of something is equal to concentration. Yes, H plus is equal to OH minus, right? So at the equivalence point, my H plus is equal to OH minus. If it's a strong acid and strong base, what pH is that going to be at? We talked about this. If it's a strong acid and a strong base, the equivalence point is going to be at what pH? 7. Right. And then we talked about if it's strong acid, weak base, it could be at different amounts, where these are equal. Cool? Okay. So let's write our R, because we're going to have to erase this thing. So R, I have, let's just start out with C, because I need to figure out I'm trying to figure out the pH, correct? Yes? So if I have my, how do I start this? Let's just start out with our Cn minus, so it's already broke up, okay? It's already broke up. The H is already gone because it's a weak acid, right? Plus water. That's going to give me what? HCN plus OH minus. I have to figure out my initial concentration. So, what is my initial concentration of Cn minus? I have how many milliliters?
50.
Okay. So I know the bottom of this is going to be over, well, wait a second, it's 50 milliliters plus, it's going to be 50 milliliters, is this with that? That's going to be 50 plus 50, right? Because I'm adding it together. 50 of that mixed with 50 of that. Yes?
Yeah.
So it's going to be 50 milliliters plus 50 milliliters. How many moles do I have? Do I have a volume here? C or no? Do I have a volume here, C or no? I'm speaking in Spanish now. Is this a volume? C. Is this a molarity? If I multiply those together, can I get moles? So 50 times 0.1 would be 5 millimoles. Because why not do it in millimoles if this is already in milliliters, right? Yes? Because 5 millimoles divided by that is going to give me an actual concentration. Yes? However you guys want to do it is fine with me. Yes? Because I have 50 milliliters of this with titrating with this, and this is a 1-to-1 ratio. So if I have 50 milliliter sample of only this, right? Yes? I know if this is the same molarity, they have to also be another 50. It's a 1-to-1. So another 50 milliliters of this is going to need 50 milliliters of that because those molarities are the same and it's a 1-to-1 ratio. Okay? Water's not part of this. Do I have any of this to start out with over on the other side? 0, 0. Change. Minus x, not part of it. Plus x plus x. E. So 5 divided by 100 is 0.05 minus x, not part of it, x and x. So this is asking me to solve for still my pH, correct? Do I have pH available on this one? I don't, correct? So I'm going to solve for Kb, correct? So Kb is going to equal x squared over what? 0.05. Yes? Do I know any of these numbers? Can I solve for this? Oh, I have Ka but not Kb, and I know that Ka plus Kb has to equal, not plus, times, has to equal Kw. Agreed?
Sure.
We just showed, that's what we just watched, right? Or pKa plus pKb is pKw.
So KB equals X.
Which means that if I rearrange this, Kb equals Kw divided by Ka.
What is KW?
Water, which is a constant, which is 1 times 10 to the negative 14th. And we also have Ka. So I know that Kb, am I still on the screen, equals 1.0 times 10 to the negative 14th divided by my Ka up here, which is 6.2 times 10 to the negative 10th, and that will give you your KB.
Why is water to the negative 14th and not to the negative 7th?
Because when you take,
The negative 7th is the individual parts of it. The H plus and OH minus are both negative 7, but together, water is negative 14th. Water's negative 14th. What'd you get, Joe?
I got 1.1, or no, 1.61
1.6 times
times the
negative 25th?
yeah.
That's not what I had. Someone check that.
that's it.
Because negative 14 minus negative 10, that should be adding.
Yeah, that's true. Oh, it's because I
Shouldn't be negative 25th. You singing Deo?
What?
You singing Deo?
Dale?
Yeah. Do you say Deo? Deo.
Yeah.
I like that.
Oh, it's negative.
I had negative 5th, which is nice.
Friday over here.
Voice of an angel. Now I've got KB. I can then put this number here, correct? So 1.6 times 10 to the negative 5th equals x squared over 0.05. Now I can solve for x. So I'm going to multiply, take the square root. What do you get for x?
That's 89.4.
What's that?
89.4.
Did you take a square root? That's not what I had. Check it again. You do 1.6 times 10 to the negative 5th times 0.05 raised to the 1/2 power.
On the problem. 8.9
8.9 times
times 10 to the negative.
10 to the negative 4th, which is equal to my concentration of OH minus, agreed? Do I want POH? I want pH. So this is equal to concentration of OH minus, correct? You guys okay with that? So what I'm going to do to this number, I'm going to take the negative log. So negative log of 8.9 times 10 to the negative 4th gives you what? 3.05, which is equal to POH. So what is my pH? 14 minus 3.05 gives you 10.95. So on this one, don't get stuck when you're like, oh crap, I have two unknowns, okay? You've got to think about what you do know, which is KW. Cool? Okay. I have one more video to show you now.